All right, hello again. We are now moving on to the second skill of the second level of the fourth part of Unit 9, which is building off of pictures of parabolas here, but specifically focusing on finding zeros. Okay, and this is kind of, if you guys can kind of remember this now before you guys get into further advanced mathematics courses, we like to use zeros to mean a couple of different things. So you'll see in our little diagrams here, x-intercepts and zeros are the same exact thing, okay? Now, the reason that we call them zeros, because it is, if you remember correctly from before, to find x-intercepts, you plug in y equals 0. That's why we call them finding the zeros. You plug in y equals 0 and solve for x. Okay? And so we can kind of get an inclination as to how many answers there are going to be if we understand the graphs that we talked about in the previous section. So certainly if there's a parabola that sits entirely above the x-axis, here's the x-axis, you can see this first picture does not touch the x-axis, therefore there are no x-intercepts, and we say there are no zeros. In this picture, you can see that it does touch the x-axis, but just one time only. So we say there's one x-intercept or 1 0. And in the last case here, you can see this parabola touches the x-axis twice. So this one would have 2 zeros or 2 x-intercepts. Now, another word that you will hear, which can get kind of confusing, but roots of a polynomial. So if you ever see roots of a polynomial, for example, if I take x squared minus 100 without the y, now we just call this a quadratic binomial, like we did in the previous sections. And if I were to ask you to find the roots of this, you would essentially do the same thing. You set it equal to 0 even though there's no y, and then you solve. So there are really three things that we can call these. We can call them zeros, we can call them x-intercepts, or plain old roots if there's no y, if it's just a polynomial. But it all means the same thing, and they're all treated the same way. So now let's just kind of talk about some of these graphing cases. So you've seen from the previous section what happens to the parent graph. Remember, this is the parent graph, and this is just a quick sketch. Parent graph sits at 0, 0. By the way, this bottom point, this is called a vertex. Okay, the bottom point of the parabola is called a vertex, and it's currently at 0, 0 for the parent graph. And as you saw earlier, subtracting after the x squared or before we square is going to shift the graph, and having a negative in front of the x squared is going to flip the graph. Okay, so for example, number 1, if I see a minus 100 after the x squared, so x squared comes first and then subtract 100, I know that this graph is actually going to shift down 100 units. And so now it's going to look something like this. So instead of having a bottom point at 0, 0, now the bottom point is going to be down here at negative 100 on the y-axis. Okay, and so now you can see, just by looking at the picture, that there are 2 x-intercepts, or zeros. Because it crosses the x-axis twice. So now, how would I find those two values? Well, let's go back and review. to find the x-intercept, or 0, you plug in y equals 0 and you solve the equation. So if you look at number 1, you're going to take y, you're going to make it equal to 0, and then rewrite the right-hand side of the equation. And now you solve for x. So using some algebra, you know that to get x alone, the first thing that we're going to want to do is if there's any addition or subtraction, we can certainly add 100 to both sides of the equation. And so now you get 100 is equal to x squared. Now looking at this, you might already know what the answer is going to be, because you can certainly think backwards and think, okay, what number or numbers could I potentially square to get 100? And if you know the answer to that, you're going to think, oh, well, that's just 10 and negative 10. Because 10 squared is 100, and negative 10 squared is also 100. Now, what we do algebraically, so the opposite of addition is subtraction. The opposite of multiplication is division. This is something we haven't talked about too much yet, but when you square something, to undo or to do the opposite of squaring, you square root. Okay? So you would square root both sides of the equation. That, in turn, would cancel out the x squared and give you just x. Now, technically, it gives you gives you the absolute value of x, but we don't need to know that yet. Just think, okay, x squared, cancel out the square because you're doing the opposite, which is to take the square root. That gives you x all by itself, which is the goal. All you have to remember is that when you square root both sides of an equation, that there are going to be two answers. And you can see why based off of the graph. Okay, 10 and negative 10. So you can either write it as plus or minus 10, or you can write your answer as negative 10 and 10. Okay, so these are the zeros for problem number 1. These other ones all work pretty similarly. Let's do number 4 together. So for number 4, if you remember the graphing that we did earlier, there's two things going on. Number 1, we have a negative in front of the x squared. So that's going to take this parent graph, and now it's flipped over, so it's kind of upside down. And then a 4 on the outside is going to shift 4 units up. And so now this is our rough sketch. Okay, and so based off of this picture, I know there are two zeros. And to solve them, you're just going to take y and make it equal to 0. And then you solve using algebra. So to get rid of the positive 4, we subtract 4 on both sides. You get negative 4 equals negative x squared. Now we can divide or multiply by negative 1. So then we get just regular positive x squared equals positive 4. And again, here's where we take that new step, or that new maneuver. To cancel out the square, you square root both sides. That gives you just x, and you're going to get plus or minus 2. Okay? And that makes sense with our picture, because we got positive 2 and negative 2 would be the two places that crosses the x-axis. Okay? So rest of the page you guys can handle on your own. On page 96, similar. I will say for number 12, I'll give you a hint or a suggestion, and that's going to be, when you're actually solving for the zeros, first you square root both sides. Okay, so you see how the square is kind of on the outside of everything. So you would square root both sides first to cancel that out, and then you kind of go forward. Okay, so hopefully that will make sense. Until next time.